Dear participants, welcome to the last session of Blockchain and IoT Refresher program. Today we have with us Professor Vipin Kumar Rathi, professor in the Ramanujam College, Delhi University. So I'll take this opportunity to introduce Vipin Rathi sir to the audience. Vipin Rathi is an assistant professor at Ramanujam College, University of Delhi. He is chairperson of Linux Foundation, Hyperledger Telecoms Inc. He is vice president at Emerging Open Tech Foundation. He is the organizer of OpenStack India, Magma India, CNCF Delhi, Open Edge Computing, Hyperledger meetups. His research interests focus on 5G networks, multi-domain orchestration, blockchain-defined networking. He is guided the research team to develop a Kubernetes-based cloud-native OpenStack named as OpenStack. He is an active member of Anuket, Magma Core. He is attended and delivered presentations at various open source summits. So Vipin sir, thanks a lot for accepting our invitation and being part of this program. And your resourceful presentation definitely help our participants, sir. Over to you, sir.
Thank you. Thank you so much. So let me start with the agenda. So I divided this whole presentation in two parts. So in first phase, I talk about what is there before blockchain, and then what blockchain changes this, what blockchain brings changes in this industry. And in the last part, I will talk about what is blockchain defined networking in terms of telecom use case. So I want to start with what is there before blockchain. This is important to understand. Like when we say blockchain, it's fine. Like in 2009, this Satoshi Nakamoto started something called Bitcoin. But what is there before blockchain? This is important to understand. Let's start with distributed data stores. So what is distributed data store is? This distributed data store is how we can distribute the data among different nodes consistently. And it contains two important parts, which is called as distributed databases and distributed networks. So when we say what is distributed network, we can understand this as distributed network is a peer-to-peer network which can hold distributed ledger, right? So as we can see here, we understand distributed data store as storing some data among different nodes consistently. That's fine, using some distributed network. But the problem with distributed data store is in distributed data store, we don't care about shared variables, which are very important once we are in the distributed computing. It don't care about locks and configuration at runtime among different nodes. So this is the problem with distributed data stores, which can be solved by distributed coordination. So what is distributed coordination is? So let's take this example of distributed coordination. It can help us in shared variables, locks, and configuration at runtime. An example is Apache Zookeeper. We all know this Zookeeper concept, and also very important concept is etcd, right? etcd is what we are using in Kubernetes as the core component. And what we are using internally in this etcd or Apache Zookeeper is Raft as a consensus. So we understand some concept of consensus by understanding Kubernetes in terms of etcd or Apache Zookeeper. So we need consensus in distributed system for fault tolerance. So now the important term is fault tolerance. So it can be crash fault tolerance, network fault tolerant, or malicious fault tolerant. So example of crash fault tolerant is Kafka. We all know Kafka things, right? But this is again a consensus thing. And when we talk about network fault tolerant, it is Paxos, or we can say Raft as it in Kubernetes. Or it can be malicious fault tolerant, can be managed by the BFT or PBFT, Byzantine fault tolerant, right? So all these things, right? Whether it's distributed data store, whether it's distributed coordination, consensus, distributed network, or distributed computing, this already exists before blockchain, right? So what extra this blockchain thing come up with? So when we talk, let's question it, like why we are moving towards blockchain nowadays. More questions is like blockchains are old because we these chained hashes kind of concepts are nothing new, right? Git anyhow uses it. So we know this hash Merkle tree concept in the GitHub, right? It's already there. And also proof of work is also not new, right? Any consensus is also not new. Anyhow, we are using a lot of consensus, and proof of work is the first one come up with the Bitcoin. So it's simply a rate limiting algorithm that's already there. And let's connect these two concepts in the distributed database. That's enough to make a blockchain. Is it enough? So that's important to understand why we always talk about blockchains, and when there is already a lot of concepts exist and can we merge them. So here the concept come of trust, right? According to ITU, we have to understand the important terms called trust. So trust of party A to B for a given task S is the measurable belief of A in that B accomplishes S dependably for a specific period P within a particular trust context T in relation to the task S. Means what? This A and B parties should trust each other with a particular understanding, let's say in terms of smart contracts or whatever. So what is a trust we understand, and what is the blockchain goals? So blockchain goals is to bring, before that, let's try to understand what is blockchain, right? Blockchain is a growing list of records called blocks, according to Wikipedia, we all know, which are linked using cryptography. And this cryptographic hash is like a connection of previous blocks, timestamp, and transaction data, and connected through Merkle trees. And on the branches, we can understand these are nothing but a Merkle tree branches, right? But this is what blockchain brings. Two, three important things is distributed trust in this whole ecosystem. So for that, we can remove the third party systems, for example, bank in terms of Bitcoin. So blockchains were built for transaction consistency in a data store, right? What is data store? We already covered, which allow us for auditability, atomicity, linearizability, durability, and most importantly, data integrity. All terms, atomicity we see in the databases, durability, yes, data should be durable, data integrity should be there, there's no mismatch. Linearizability is when majority of nodes returning the same value. That's what we do in the in the blockchain parts. So now we understand this blockchain issues, right? There was blockchain previously, and there was concepts like blockchain, for example consensus or git, or consensus in terms of whether it's, and consensus is important to understand. This is nothing but to maintain the fault tolerant in the distributed system, whether it can be crash fault tolerant, byzantine fault tolerant, or election leader, which is like a proof of work raft. These all concepts anyhow we are using in different applications, whether it's Kubernetes, cloud, or a lot of other applications. Now, important is we have to understand three differences: blockchain versus distributed databases versus distributed storage. These three things are very different. Blockchain is very different from distributed database. Sometimes people say that, okay, the blockchain is nothing but a database, although we, let's say, distribute this database, make it more distributed way. Or distributed storage, for example, IPFS, interplanetary file system. People say, okay, we can we can store this data into multiple location, make it distributed, and we can say this is a blockchain. So the difference of these concepts are really, really important, because if I compare this with a distributed database, these distributed databases are centrally managed, right, by a service provider, anyone. Let's say a company is managing distributed database. And also the scalability is so important, because we can scale these kind of distributed databases. Why? Because of central nature of the system. And also in distributed databases, there is a node duplicacy of record exists on each node. But in blockchain, when we start, let's say for the Bitcoin or Ethereum, what we do initially, we download whole blockchain and then only we start, whether it's a distributed storage in terms of blockchain, with the example of IPFS. So this is really important to understand that what is there before blockchain, right? And what blockchain is bringing changes in this whole system. Those who are new to the this world of blockchain, I want them to just Google some words. For example, for consensus, just search proof of work, proof of stake, raft. these are important one, Byzantine fault tolerant. Why? Or honey badger. Why? Because as I told you, Raft is so important. Means any distributed application in this world, like most of them follow Raft, right? Was once in terms of blockchain, like most of the blockchain follow proof of work, now shifted to proof of stake. And when we come to the private blockchain part, then most of the blockchain follow either BFT or PBFT. Depend on the use case of the application. For example, it can change based on the application, let's say, or use case. For example, iota is only for IoT, so that's the use case is different. That's why they are using different consensus mechanism. Based on the use case, this consensus mechanism get changes. Also, cryptography is so important for the blockchain parts, whether it's a public key infrastructure, symmetric key, asymmetric key, public private key pairs, or shared secret in terms of AES keys. Which one is fast, which is not? For example, asymmetric keys, right? In asymmetric keys, asymmetric mechanism, what we do is it's really slow. Why? Because we need public private key, digital signature, a lot of things, right? So what kind of encryption mechanism I should use so that I can scale my system? For example, Bitcoin or Ethereum, they're using elliptic curves, right? But the problem, and especially why this is really interesting to know that why Satoshi Nakamoto choose different elliptic curves than that's what industry is using. Because in 2015, NIST already um, published one report that try to use different elliptic curves, right? Because this encryption can be breakable, especially in the quantum era, right? So that's why they want to shift it to now the post-quantum encryption. And also now there are in Bitcoin or Ethereum, there is a improvement proposals, right? Bitcoin improvement proposal or Ethereum improvement proposal, where people are now shifting towards post-quantum encryptions as well, whether it's a Frodo-KEM or Kyber based on the again use case. Or ZK snarks, again, important. Zero knowledge proofs are really important for the privacy reasons. Right? Initially, it started with ZK snark, then it's moved to the Stark. And nowadays, I, I hope you understand layer of these blockchains. For example, nowadays people say layer two solutions, right? What is layer two solution is whether we can push our data more on the side chains and can get access, can increase the can scale this kind of blockchain. For example, in Ethereum now, layer two solutions are more important. Why? Because of let's say miner fees or whatever. So what they are using nowadays is ZK rollups or ZK sync, so that they can use these privacy as well as they can scale the blockchain by using sidechain concepts. So if you are new to this blockchain world, just try to Google out some ledger concepts as well, whether it's mining, what is miners, blocks, forks, let's say. So this blockchain, for example, Bitcoin forks happened in, let's say, in 2017. And then parents, uncles, and Merkle trees. And Merkle trees are really important, right? Because anyhow, we use these kind of Merkle trees in whole distributed system, for example, GitHub. And platform concepts, nodes, oracles are very good in terms of if you want to talk to third-party APIs, then oracles play a very important role with respect to blockchain, wallets, and smart contracts. So if you are new, just try to search for some words that will help you to understand this concept in a very important way. Also, I want to add very important point. This is called homomorphic encryptions, right? There are different encryptions now growing because of computations. Now computations are getting good day by day. So people nowadays, even in the cloud industry, now everyone try to shift to the homomorphic encryptions. This will help you to store the data in a more protected way. Means you can apply all the AI kind of things without knowing the data. So these kind of encryptions can also be used in blockchain. So depend on the use case. Again, we can use a lot of other things. For example, whether it's a post quantum blockchain, whether it's a different encryption mechanisms or scalability. If layer two solutions, for example, from India, there's a startup called Polygon. What they are doing is they are providing more layer two solutions and helping in terms of privacy as well by adding zero knowledge rollups or ZK syncs. So these things can be done only when we understand the basic principles of cryptography and how our current infrastructure works, right? And based on this, we can divide our blockchain into two parts. There's a types of blockchain which is called public and private. We permissionless, right? Anyone can join, anyone can perform rewrite operation, but it's restricted to mostly on the participant sides, right? Who is participating in this permission network. Participants can be any anonymous, malicious, here known and trusted. Low energy consumption. The currently the problem with the public blockchain, whether it's a Bitcoin or Ethereum or other blockchains, is high energy consumption because of proof of work. But some of the blockchains are now shifting towards proof of stake so that they can decrease these kind of high energy consumption. Transaction per block is less, of course, because of because these kind of public blockchain are more distributed in nature, and transaction per block is high because the only permission or only restricted people are accessing this kind of network. But this is we call generally as an enterprise blockchain. Enterprise means companies are using. For example, let's say even we are using this. So, for example, in our case, what where we are using this private blockchain is for to generate the certificates. So these kind of network we can access in a very fast way. So transactions are very high, and again, if you can see this difference in consensus, there is a proof of work, proof of stake, proof of authority as a consensus, and the example are Bitcoin, Ethereum, etc. Here we can see that this is Raft, BFT, PBFT kind of thing, Byzantine fault tolerance, or Honey Badger. And the important example are Hyperledger. This is Linux Foundation umbrella project. Hyperledger R3 Coda is also very important. So these are two important private blockchain networks, which generally people use in enterprise stuff. So let's continue with this. Okay, we know now what is there before blockchain and what's happened after blockchain. There are a lot of changes happening now after blockchain. So what and how it affects this telecom industry, especially or networking world in with how blockchain affects this. There are numerous examples. I want to cover this do not disturb DND. This is what Indian government started, I think, this project in 2017 with all the major telecom operators in this country. And what they did is they used now DND to on blockchain, and they are now testing this out. This is, I think, in the testing phase, and I think most of the tests are completed, and soon they will implement this in the with all telecom operators in this country. Also, there's a network slicing now. For example, use cases, for example, IoT or AR VR. Nowadays, these technologies are mostly based on 5G part. So we will talk about this network slicing more, so that you can understand how it you can relate these in terms of IoT and AR VR applications. Inter-carrier settlements or telecom has a lot of use cases for the blockchain. We will take care one by one. So, for example, these verticals you can understand in telecom, or especially in the networking world, we have software-defined networking. So initially in 2008, generally this concept of software-defined networking came, and then this moves to the ITSI, means the standard bodies move to the NFV, network function virtualization. And nowadays, like most of the people are following CNF, which is cloud native network functions. So this is the one of the areas where nowadays most of the telecom operators are looking to use blockchain. Again, you can use it in the roaming, whether it's a wholesale or especially in the wholesale part, we use roaming for this blockchain, or we can use it in the BSS OSS. There are a lot of use cases, IoT services, vendors and partners, cloud, and anything as a service. Also nowadays, we can use with the help with blockchain. And the application can be asset management, identity management. This identity management concepts come within blockchain's DIDs. DIDs, let's say Hyperledger Indy is using this DID concept so that they can manage these identity in a better way or more distributed way and more anonymous way. And the smart contracts, registries, and other things, they are payments tokens. That's what we can use it in a telecom use case or networking use case. But we have to understand few things before I start about networking. See, network connectivity, whether it's through radio or whether Wi-Fi or broadband. See, nowadays everything is interrelated. Whether it's because, for example, cloud computing. Take the example of AWS. Now, all the big public cloud operators, whether it's Amazon, whether it's Google or Microsoft, what they are doing is they are also now becoming day by day some MVNO. What is MVNO? Is mobile virtual network operator. So what is this? So now you will see in future, like most of the telecom operators take support of these cloud computing companies, right? Or whatever network connectivity we do, whether it's 5G, 4G, it's also the important part, like nowadays data, big data or other applications can be overlap. But the problem with this area is a trust, right? Because these are like different players. For example, in the cloud computing, two different cloud operators talking to each other or sharing some data. So obviously there is a trust issue. So trust in terms of security and privacy, right? Before I start again, I want to little bit give you a little bit introduction, especially about edge computing, because edge computing, due to edge computing, only this whole centralized nature of networking is now shifting towards more distributed nature, and that's what distributed computing is so important in terms of edge parts. So edge computing is what is compute that's closer to the consumer, right? Or some people say is a bumper of a car or something. Edge is anything that's not cloud. So by this example, we can understand what's going on in especially in the networking world. So from more centralized approach, we are moving towards more decentralized approach in terms of edge computing. So whether any infrastructure means what nowadays infrastructure means what nowadays these standard bodies are pushing more on like openness. So any infrastructure means any hardware we can use. We call this as a COT servers. COT servers means you can use any company server and you can use whatever code you want to run on. So there's no vendor lock-in nowadays much in this open world. So from LTE days to the VPC is what now this everything is virtualized in terms of 4G, and then moving towards IoT. Mac is what we call as a multi-access edge computing, is nothing but edge parts to vRAN, now ORAN to 5G. So this way you can understand how technology is shifting towards more decentralized nature. So once industry is moving from centralized to decentralized, then there is a very good scope of blockchain parts, right? Because anything what we want nowadays is a zero touch automations. Now, what is this? Also, for especially for the IoT, I want to give you one example. Here, let's say before this IoT example, I will give you in the, let's say in this example, and I want to start with what is different layers in the case of networking world. So this is, let's suppose your mobile device. So mobile device is connected to radio. Radio is nothing but a tower. So it's connect via backend is connected via edge, and this edge is running nothing but a one network function. Network function is nothing one code, let's say. So network functions, there are multiple network functions running out here at the infrastructure layer. So core means what, where are we running cloud kind of things. So we can understand at the network function layer and where blockchain play a very important role is this slice part. So this is called network slice. Network slice means what? This is a, let's say, network function 3, 4, 5 we can take together and can make a slice of it, and this slice can be used for multiple applications. Take the example of URLLC. What is URLLC? Is ultra reliable low latency communications. This is very important for IoT parts. So for example, this slice can be for massive IoT devices or NB-IoT, narrow band IoT, or this slice connectivity happening across multiple networks. So this slice connectivity happening in the multiple network. I will show you what by a diagram what I mean by multiple networks. Multiple network means multiple entities. When multiple entities come out, then there's a issue of trust. And where we can use, when wherever there's a trust issue, we can use blockchain. So the overall idea behind this is that, so any application, whether it's IoT slice, whether it's AR VR slice, so this slice can be, let's say, AR VR slice. So booked for AR VR application, let's say for healthcare, for education, for whatever verticals. But here our whole slice can be booked for, let's say, IoT, and we can do a lot of operations. So we have to understand where we can use blockchain in any field, in, let's say, in terms of networking, but everything is nowadays is a communication, especially in 5G cases. For example, AR VR, we can use this for any industry, but the communication is needed internally. We need some slices to work out, right? So there's a slice composition, and this slice one is nothing but some service giving to the third party APIs through slice management parts. Back to this, so you can understand this core data centers are now distributed more distributed ways, right? Whether in terms of again to the SDN, NFV, or VNFs or CNFs parts, we can understand nowadays this distributed nature are so important in terms of edge computing, and there is a very good scope, especially for blockchain use cases. So application platform, any application platform for telco consumes data, delivers data via the infrastructure platform, and then enable this whole pipeline of CI/CD and this secure agile DevOps environments. But the important part is that at the top we can use any application, whether it's Mac, IoT, or blockchain. So this works over OSS, BSS. Operational systems are so important and they're so costly. And if we can remove third-party verifiers and can use smart contracts and can replace all these middlemen and can be directly talked to blockchain. So that's what open-ended questions for in case of networking are E2E, end-to-end slice management in SDN, NFV, edge computing, 5G. So this is what all these things are for networking, for communications parts. So end-to-end slice management. In this case, we can understand this. There's an end-to-end communication we need, right? And how we can manage, and if we can manage it, and then how, which through which we can manage it. So we this end-to-end slice management is only possible through orchestrators. For example, um, in Kubernetes is a kind of orchestrator which is managing multiple workloads, distributed workloads. And trust relationships are very much central for all telecoms, right? Whether it's Geo, Airtel, so they cannot share data like this. Like they cannot share data as such because there's a trust relationship always between them. So how to control various SDN controllers from one orchestrator? This is really important application, and nowadays becoming more and more famous in case of 5G, because nowadays the slice sharing happens between multiple telecom operators. You can understand this example by let's say you have a Tesla car or auto, or this Tesla car will share this antennas across the road with different multiple telecom operators. So how this slice can be booked from end to end and how you can manage this. So these are the applications where we need blockchain to manage as an intermediary. How to distribute database between different telecom operators and how to manage this inter-domain transactions and billing. So these are some open-ended question in the telecom world, in the networking domains, and that we can understand. For example, these are different telecom operators. Take the example, let's say this is Geo, Airtel, or Vodafone, and this overall managed by the some management controller, let's say SDN management controller at every at the top of every telecom operator. So what they will do is they will make a blockchain over the network. This is like overlay network of blockchain and put some smart contracts and can manage at least at the some kind of life cycle management so that we can remove the untrust between the different telecom operators. Also, for example, communication between data user and data provider as well. So if we see this diagram, there's a data registration happening and access management. Trace management is really important. For example, sometimes people say, okay, I haven't done this, or this activity is not done by me or something. This trace kind of or log management can be stored on blockchain. And this data directory again, these concepts again come from the distributed ID concept, DIDs. So that there are a lot of use cases what we can do in case of networking, how data is exchanged between different entities, and then we can add this data exchange layer can be a blockchain, right? So that we can manage it in a perfect way. So there are federated platforms. For example, nowadays cloud or fog become more decentralized, and what telecom operators or other people are doing is they are using sidechain to make this whole system more fast. And this is nowadays more in the standards as well, that how different cloud operators can communicate, and then they can use blockchain as well. Also, same example, but with the multi-domain orchestrators. Multi-domain orchestrator example I want to show you in this one. First, let's understand what is multi-domain. So for example, this is my radio unit, my tower. This tower will talk to some DU. In 5G, we have a distributed and unit and control unit. So let's suppose this is Geo, this is Airtel, or this is Vodafone. So what will happen once the data goes from DU to CU, and there's always a edge service orchestrator. So let's suppose this is a Geo service orchestrator, right? And this is Airtel, and this is Vodafone. So this multi-domain edge service orchestrator will talk to three of them and take all the necessary exception decision to make all the network slices. See, important case for industrial 4.0 especially is these network slices from one operator to another operator. But the biggest problem we face is a trust issues. Why should I believe in this? Why should believe I this telecom operator or networking equipments? So this thing can be solved by blockchain. That's what we are using blockchain at this level to handle, to take decisions in a more unbiased ways, right? Or this communication. Let's suppose I'm taking the example of 5G, but you can take the same example with the LoRa, right? LoRa is what? Low power wide area network, LoRaWAN. So we make a communication for IoT through LoRaWAN, right? So for example, I have a LoRa devices, and this LoRa device is connected to LoRaWAN hotspots. And I don't know how many of you know about Helium. So Helium is a blockchain. In US or in Europe, they use this kind of blockchain to incentivize their network. For example, you can run a device, a LoRaWAN device for whole IoT network, and you can share your IoT network with anyone in around you by using LoRa. In that case, you will get the Helium coins, which you can sell it over some exchange or something. So these kind of new application will come out in the future. So Helium is now becoming so famous, but the application remains same. That once you want to share your network, and you don't trust the next person, what you will do? Just run a blockchain node, and this blockchain node will give you incentivization in terms of tokens or whatever, and then you can earn money as well. So this kind of network in the future will be more common, especially in the private 5G cases. So in this multi-domain orchestrator, anyhow, you can use a blockchain. As you can see, there is a one SDN controller, and this SDN controller talks to orchestrator, and this orchestrator talks to blockchain. And this blockchain is nothing but containing a node with all the certified authority, peer order kind of things, right? So this kind of things we can, of course, if you can see SLA breach is happening or not. If there is a SLA breach, then at that moment only you can trigger the transaction, and the money will deduct from the respective telecom operator to another telecom operator. So this kind of network, so that we can bring more trust in the system with the help of blockchain. So this is another paper we published in Telecom SIG. What we are doing is how roaming is a very inter-carrier settlement, we call this. Inter-carrier means what? If there are two telecom operators, and They are using, means of course everyone use, every telecom operator use other network as well, so they charge for roaming for inter carrier. So this can be solved very easily with the help of blockchains, right? And this is the framework we designed for. This is reference architecture from our side, that of course we can use some Hyperledger Fabric or some other enterprise blockchain to solve this issue. Our interoperability is also important, as you can see here. So Hyperledger should talk to Ethereum as well. It's not like that only one chain will talk to one chain. So the communication between different chains is really really important, because in future you will see there will be many enterprise blockchain, and these enterprise blockchain should talk to either public or private. Same way we do in cloud parts. So in cloud we have public cloud and the private cloud. But nowadays people focus more on the hybrid cloud. Hybrid cloud is what? Let's suppose you have let's suppose in the private let's suppose you have a private cloud, and you want to share your workload on the public cloud as well. So this will become hybrid nature of the cloud, as we can see in this diagram as well. Let me show you. So this is multi-cloud is what? Between different public cloud, but we can do the same thing, hybrid cloud, between public cloud and the private cloud. So what is the objective, right? So what I'm saying is, overall, there are a lot of applications of blockchain, especially in the OSS PSS part. So ONAP is again one of the good open source project to manage all these telecom use cases, and where we can apply blockchain to any networking equipment. So for example, in OSS PSS, we can do is for the audit and SLA management. And a very important thing is service change event based for on smart contract. For example, let's take the example in the data center. If you put one pen drive, so there will be some change, right? So let's suppose who made this change, this service change event, and that's what we can store on the blockchain, and later we can see, okay, who changed it or not. So inventory asset and relationship among assets, that can also be managed. And we can add, for example, whatever your software is end to end, we can add blockchain layer at the end, so that data can be pushed to the blockchain through APIs. That also can be done. Same thing, but more in the open ecom also. Nowadays, people are trying to use this blockchain infrastructure for identity management, access management, configuration, manipulation, prevention. This is important, because sometimes nowadays in this networking world, so many things getting so much automation. So this automation happening, for example, if I run some script, it might possible that it breaks some other thing as well. So this configuration, manipulation, prevention can be done through smart contracts as well, and constant monitoring and verification. So if some changes will happen, then smart contracts can be triggered to solve some problems as well. Sorry. So this is the Internet of trusted things and blockchain. This is what blockchain can be used in lot of places. For example, from supply chain. Anyhow, nowadays everything, as I said, is connected, but there's the issue of trust that can be easily solved with the help of blockchain. So as you can see, from supply chain to IoT network management or end user authentication, on demand asset sharing networks to smart contracts and compliance. This is a whole end to end life cycle of nowadays how things are working. So in this whole network, this blockchain play each and means blockchain can play a very important role at each sections, right? For example, communication in between this two, three, three, four, four, five, everywhere, right? Because of security, identity, and how these transactions can be managed centrally or in a more distributed way, not centrally. And I want to end with this. Find the right fit. It's not like this. So, for example, boss is asking, where should we focus this year? Let's say blockchain. It will change everything. Everybody is talking about it. The potential applications are endless. We don't want to be left behind. What exactly is blockchain? Also, artificial intelligence. I hope you understand this job. And with this, thank you so much. And if we have more questions, let me know.
Participants, if you have any questions, please unmute and ask. Okay, Vipin sir, thanks you very much. I think there is no questions from the participants. So
Mhm.
thanks for your valuable time with us.
Thank you. Thank you so much.